Uh, Students, we were discussing this sum from the wave section, the numericals we are discussing. And students, one thing you must notice that for the in finding the frequency, that is your part B question of sum number 1, I've written 70 CPS. Okay, CPS means cycle per second. All right, but also if you want to write it as hertz, then also it's okay, but often in some earlier days CPS was used. All right, that is cycle per second. Okay students, I think this sum is clear to everyone. The formulas and all, or everything I've written. Okay, you have to compare. In short, I'm telling again, you have to compare the original equation, that means the equation that we have studied in the theory classes, with the equation of the equation that is given in the question. Okay, then only we'll able to find out each and every question. All right. Now students, let's move on to your next sum, that is sum number 2. Okay. Okay. First of all, I will dictate the question, explain it, then I will move on to the solution. Okay. So your question is, a wave is propagating along the negative x-axis with the vibrations along the y-axis. Okay. So what you're having, a wave is propagating just in the negative x-axis and its vibrations is along the y-axis. So alright, its amplitude, frequency and wavelength are respectively, the data are given for this amplitude, frequency and wavelength. Okay, that is for the amplitude, so its value is 0.10 meter. For the frequency, it's having 500 hertz, and for the wavelength value is 1 meter. Now write down the equation of the propagating wave. So that means in which direction the wave is propagating, that is in the negative x-axis, it's given, and how in which direction the vibrations are seen, that is also given, that is along the y-axis, and respective parameters are given, that is your amplitude's value, frequency as well as the wave. Now you have to find out just the equation of the wave. Okay. So students, for this particular sum, if you just go through the formulas, you will see that the equation that we require for this type, that means depending upon the data given in the question, students, we have to pick up the formula from our mind. Clear? So I've seen all the data that is given in the question. That means students, I am getting here the frequency. Okay, so in short I'm writing, I'm getting the n value here. What are the other values I'm getting? I'm getting the amplitude A. I'm getting. What is the next thing that I'm getting? I'm getting the wavelength. That means your lambda part. With all these three values I'm getting. So I will choose this equation, that is y equals to a sine 2 pi n within bracket t plus x by v. Okay, see all the things that it is given in the question. A value is given, yes. Your n value, that is your frequencies value, is also given. Okay, the details I have not written it. When I will solve the sum, then you will able to see the respective datas. Okay, and yes, and your lambda value also we can able to calculate. That we will see, students. Okay, how you can find out the value of this lambda? Okay, so you know the velocity of the wave is written by this formula n lambda, that is a wave velocity equals to frequency into a wavelength. Previously I have also written this formula, again I am taking this, that is v equals to n lambda. Okay, so why we are taking this? Because the lambda value is already given in the question. Okay, and yes, and your x and t, that means your x and this t, see the two parameters in our original equation. This is our original equation. Okay, okay, so your x and t are in the terms of meter and second. Okay, so let us write the equation. That means just put the values in this main equation. So let us write that. So y equal to, what is the value of amplitude given in the question, students? Your amplitude value is your 0.10 meter. Alright. So let's write that amplitude value, this 0.10. Okay. Let's write the sine 2 pi. After this, let's write the value of your n. What is the value of n given in the question? Your frequency's value is 500 hertz. Okay. So I'm writing here sine 2 pi into 500. Okay. So after this, I have to write this t plus x by this v. Now I will calculate, okay, from this particular thing. Okay, so just let us calculate here and then I will place it in the original equation. What will be the value of v? V will be equal to n. What is the value of n? 500. That is the frequency's value, and the lambda's value is your 1 meter, that is 1.00 meter, 1 meter, whichever term you want to use. Okay, so finally we'll get it as 500 only. 500 into 1 means 500. So 500. So I'm just placing it here in my main equation. That means the equation that we are calculating, right? Okay. So t plus x by 500. Okay. Obviously, please don't forget to write this term meter. Okay. Very easy, some students. Repeating, students, once again from the beginning what we did. First of all, the datas, the value of frequency, the amplitude's value, and your lambda's value, that is the wavelength value is given in the question. Depending upon these three parameters, I have to use one formula where I will get all these three values, all these three parameters. Let's check. I am getting here this amplitude, this A part I am getting from the data. N part, yes, that also I will get. T and x will be the same only. You have to express the equation in terms of t and x. So don't worry about this t and x. Now what is the main thing? I have to get the value for this v. Alright. Now when the three data parameters are used, you are being left with only lambda. So just making this thing very short to you all. So you have to recall one formula where I will get this lambda value. That means for finding out the value of velocity, I can use this lambda. So yes, I did. So my formula for v is v equals to n lambda. So yes, I calculated the sum.